Okay, yesterday we talked about end behaviors. We talked about zeros. We talked about multiplicity. On your quiz, you guys are going to have a function similar to this, and it's going to say, tell me all of the stuff. Tell me the end behaviors. Tell me the multiplicity. Find the zeros. And you are going to have to graph. Very basic sketch of a graph. I'm not looking for anything major. I do need to see that the ends of your arrows are going in the correct directions, and I need to see the axis, x-axis, the action at the x-axis. What is going on there? So we'll talk about that in a second. But if I'm going to determine the end behaviors of this graph for letter A, first I need to make sure that my polynomial is in standard form, correct? Mm-hmm. Is it? Yes. Okay. So then I look at the highest exponent, which is what? 3. Think in your mind, guys, is that an odd number or an even number? Odd. It's odd. When we think of the word odd, we think of what direction of the arrows? Opposite directions. Good. Okay, so in your mind, you can get a little picture. Our odd functions are going to represent either a linear or a cubic. So a positive or negative. This is positive or negative? Positive. So it's going to something like this, right? Have some more twists and turns in the middle, but something like this, correct? So what is the end behavior? Left to right. We read left to right. We write left to right. The end behavior on the left-hand side, it is falling left. Great. And rising right. Perfect. That's exactly how you are supposed to answer that question. If you have a question about that, guys, ask me. But you look at the left-hand side of the graph, see what direction the arrow is, rising or falling, and then you do the same thing on the right, okay? So now when we talk about the zeros, when you find the zeros of a function, you plug in 0 for y. You're setting your function equal to 0 and solving. In a sense, guys, all you're going to do is factor. You take out the GCF. You look for difference of perfect squares. All the stuff that factoring can entail, you guys will see. What can I do here? I can take out an x, right? Looking at this from the very beginning, how many zeros should I have? 3. 3x equals, okay? So if I take out an x, I'm left with x squared minus 3x plus 2, correct? Can I factor that more? Good, you guys. Awesome. So x what? Minus 2x minus 1. Perfect. And now what do I do to each piece? Perfect. X equals 0. X equals 2. X equals 1. Very basic. Now we talk about multiplicity. Multiplicity means you have the same root, the same 0, the same solution more than once. A repeated number of times. Do I have multiplicity? So on your quiz, when it says state the multiplicity and there's going to be a line, you guys don't you necessarily have to write it on the line. You can just go like this. No multiplicity. You guys showed me, if I could spell the word, you showed me that you solve for your x's, and now you're telling me there's no multiplicity. Question. Okay, so now we have no multiplicity. We told the end behaviors. I see what my x's are. Now we have to graph, right? And when we graph, we're going to talk about what is going on along the x-axis. We want the action at the x-axis. At each point, x is 0, x is positive 1, and x is positive 2. What is my graph doing at each one of those points? Is it going through or is it bouncing? Is it touching and turning? It's going to go through. It's going to cross through. We'll say cross through.
Crossing through because there's no multiplicity.
Correct. At each x intercept. Now, let me rephrase that. It's crossing through because there's no multiplicity that occurs an even amount of times. If you had x equals 1 3 times, like if you had, Madison, the cube,
multiplicity 3 times,
it'll go through. If it's an odd number of multiplicity, yeah, generally you either see an x-intercept once or twice. Very rarely you guys going to get like, you know, x equals to 4 times. But, you know, sometimes it happens. Uh-huh. It's going to ask you, hold on, not all at the same time. Mateo.
There would only be 2 turns though, right?
Correct. But they're there's a line that says what's going on at the x-axis. You don't have to write it on the line. If you answer like this, I'm fine because I'll see all the answers. Now think about, this is where you guys are going to get a little messed up and there's no reason to. Think about the end behaviors of your graph. What did you guys tell me it's doing? On the left-hand side, do you guys agree that that arrow is going downwards, it's falling? And I'm rising over here, right? Agreed? So we read left to right, we're going to draw our graph left to right. At each one of those dots that I have at x equals 0, x equals 1, x equals 2, is my graph going to go through those dots or touch and turn? You already told me it's going to go through. I don't care how tall you guys go, just make sure, watch. Start here, I'm going to go through 0, back down through 1, back up through 2. What I'm looking for is that your arrows are in the correct direction, that your intercepts are in the right spot, and that the action at the x-axis, what happens at the x-axis is correct. Did you touch and turn or did you go through? I'm not looking for a precise, it has to be perfect. I need a general sketch, but do you guys see that? Do you understand? Okay, all right. We're gonna go through a couple more, I promise. Let's go to the next one. Let's look at it. Because most of you, I got a couple emails over last night and it was like, I get this except for the graphing part, which is fine. You know, it's new. It's a different kind of concept. All right, even, odd, positive, negative. How do I figure that out? Put it in standard form first. Good. I'm going to rewrite this with my highest exponent first. It's a positive x to the fourth, a positive 3x cubed, and a negative 4x squared. And I'm already going to set it equal to 0 because I know I'm going to factor it. If we're talking about end behaviors, guys, what's the highest exponent you see? It's a 4. 4 is what kind of a number? It's an even number. And when I think about even, what direction of my arrows do I think of? The same. Very good. So remember, our even functions might have some extra bumps in the middle, but it's going to resemble a parabola. Is this a positive x to the fourth or a negative one? Positive. So both my arrows are going to be going which direction? Good. Very good. So my end behavior, what am I doing on the left-hand side of my graph? I'm rising left. That's the first question that you're going to answer. And I'm doing what? Rising right. Perfect. Questions? Good job. All right, now we're going to find the zeros. Well, when we find the zeros, we set our equation equal to 0 and we factor. GCF? What can I take out of all three of these terms? X squared. Good. Then I'm left with x squared plus 3x minus 4 equals 0. We all know how to factor that. X plus 4, x minus 1. I agree. And now what do we do to each piece? We're going to set each piece equal to what? Now, at the very beginning, you guys should have made a little mental note and said, okay, how many x equals should I have for my answer? You should have 4. How many equations do I have written that are set equal to 0 right now? 3, okay? Don't get fooled by this. Don't get fooled by this. If I take the square root of both sides, when I physically take the square root of a number, what goes in front of my answer? Plus or minus. Now, obviously, guys, this is a special case. This is why we put this on here. If I gave you x squared equals 4, you would tell me that my answer was plus or minus 2, correct? Is there a difference on the x-axis between positive 2 and negative 2? Yes. Yes. If I gave you x squared equals 9, is there a difference on the x-axis between positive 3 and negative 3? Yes. In this case, is there a difference between positive 0 and negative 0? No. I understand that there is no negative 0, but just get in the habit of always putting the plus minus because you'll very easily miss this root. Over here, this is x equals negative 4, correct? And this is x equals 1. So the next question line says to state the multiplicity. Okay, you found the zeros, state the multiplicity. Do I have multiplicity? Yes. Where? Yep. You have multiplicity here. 2 times. Hold on, I'll show you. I have multiplicity there. Do I have multiplicity at negative 4 or positive 1? No. So this changes what my graph looks like. Because when we have multiplicity, what's the action at the x-axis? So here, it's going to touch and turn, or bounce. And what's it going to do at -4 and 1? It's going to cross through. This is exactly how you guys can answer on your quiz if you would like to. You do not have to write everything on a line.
So you don't have to do a graph, you can just.
Yeah, you're going to have to graph, but I'm saying like this, like there'll be a line that says state the zeros and the multiplicity. And then underneath it, it says tell me what's going on at the x-axis. I'm fine if you write it like this. Like you're answering the x's, you're telling me the multiplicity, then you're telling me what's going on at the x-axis.
So it's touching and turning and going to the x.
Correct. Watch, this is what it's going to look like. First thing I want to do is just get a mental picture. Where is my graph coming in contact with the x-axis? At -4, 0, where else?
1.
And at 1. I'll have a coordinate plane for you very easily for you to see. Now, what were the end behaviors of my graph? Both of them up, right? You guys agree that both those arrows are pointing up? So think, before you draw your graph, what is happening at -4 and +1? It's going through, and then what does it do at the 0? It's going to touch and turn. So watch, we're going to come down, we're going to go through 0. Doesn't matter how far you go down, just come back up. You're going to touch 0, turn back around, and then go back up through 1. That's how you create your graph. You showed me right here. Okay, there's my intercepts. Oh, look, it did. It went through -4. It went through +1, but it didn't go through 0, just touched it and bounced off of it, went the other direction. All right, let's look at this next one. Let's figure all this stuff out. First of all, are we in standard form? Yeah, okay, good. So then we can start to tell stuff right off the bat. What kind of a number is this? It's an even number. So what's the direction of my arrows? Same, good. Is this positive or negative? Positive. So they're both going to be going in which direction? So what's my end behavior? Good job. Rising left, rising right. Very good. So now we're going to say, all right, let's find all the zeros and that good stuff. So 9x to the 4th minus 54x squared plus 81 equals 0. GCF.
9.
Okay, take the 9 out. I'm left with x to the 4th minus 6x squared plus 9 equals what? 0, okay. How many x equals should I have? 4, okay. Can I factor x to the 4th minus 6x squared plus 9? Yes. On your quiz, I made sure everything factors. It may not be super apparent and jump right at you. You might have to think a little bit, but it'll factor. So what times what's going to give me x to the 4th? X squared. Good. I hear you, Julia. And then what times what is going to give me a -6 when I add, but a +9 when I multiply? -3 and -3. Before you guys go any further, is there going to be multiplicity here? Yeah. How do you know that?
Because there's a square.
They're the same, right? X squared minus 3 and x squared minus 3 are the same. So you know you should have multiplicity. In your brain, you should also think, ooh, that means that whatever the multiplicity point is, what's going to happen to my graph? It's going to touch and turn. Good. So let's set each piece equal to 0. 9 equals 0. Not true. X squared minus 3 equals 0. And x squared minus 3 equals 0. Some of you are going to say, do I have to write it out twice? You don't have to. But if you just tell me that you just have plus or minus √3 and don't tell me multiplicity or something like that, then you're missing 2 of the roots. So I would show as much as you could. If we move the 3 over, I have x squared equals 3 in both cases, correct? Yeah? And then what do I do? Square root. When I take the square root, what goes in front of my answer? So plus or minus 3 here, and x equals plus or minus 3 here. Now, do I have multiplicity if I had just that as an answer? No. The square root of 3 and the negative square root of 3 are different, right? They're in 2 different spots on a graph. But since I have the same answer twice, what I really have here is x equals the square root of 3, x equals the square root of 3, x equals negative square root of 3, and x equals negative square root of 3. I have 4 roots. There's 2 at x equals root 3 and 2 at x equals negative root 3. Do you guys see that? You are fine to leave your answer like this. If you want to write it out, that's fine. But do I have multiplicity?
Yeah.
Where? Good. I have multiplicity 2 times at x equals root 3. And I have multiplicity 2 times. I have 2 sets of multiplicity at negative root 3. And that's really important because, so where does the graph touch the x-axis? At negative square root 3. So you guys are like, okay, think about this, guys. In general terms, what's the square root of 1? 1. And what's the square root of 4? 2. So the square root of 3 is in between what 2 numbers? 1 and 2. Okay, so here's 1, here's 2. I'm going to say that right here is positive square root of 3. So negative 1, negative 2. I'm going to say it right here is negative square root of 3. Does that make sense? All right, now think about it. We're just doing a general sketch. What was the end behavior of this graph? They both were going up, right? And what is happening at negative and positive root 3? Does it go through or does it touch and turn? Why does it touch and turn? Because you have multiplicity 2 times. Good. So I'm going to come down here and I'm going to touch this root and then I'm going to bounce back up. And then I'm going to go up to whatever, it doesn't matter. And then we're going to come back down and then we're going to bounce back up. So you guys are showing me, again, I'm not super concerned about how high or low you go. I just need to see you guys make an attempt at making some smooth turns. But I need to see that your arrows are going in the correct direction, that you have the correct amount of bumps. How many bumps should I have in my graph? How many should I have? 3. I have 1 here, 1 here, 1 here. Turns, whatever you want to say, I'm sorry. You can, if you do this, I'm going to mark it wrong because that's not correct. Generalities is what I'm speaking. I don't need to have everything precise, but you have to have the general characteristics correct. Yes, sir. So here we go. Let's put our function in standard form. So I should write 4x to the 4th minus 3x cubed, right? Minus 16x squared plus 12x equals 0. So let's talk about our end behaviors. End behaviors. Highest exponent I see is 4. That's an even number, right? So I think my direction of the arrows are going to be the same. It's going to resemble a parabola. Some more bumps in the middle, but that's okay. And it's a positive 4x to the 4, so that's why both arrows are going upwards. So we're going to say we're rising left and rising right, correct? Okay. All right, now let's factor. What can I take out of all 4 of these? I can take out an x. So I'm left with 4x to the 3rd minus what? 3x squared, good. Minus 16x plus 12 equals 0. Okay, so I still have my x out in here, and now I'm going to group since I have 4 terms. What can I take out of 4x cubed and negative 3x squared? An x squared, and that's going to leave me with 4x minus 3. Okay, what am I going to take out of negative 16x and 12? If I take out a 4, that leaves me with what? 4x minus 3. Since I took out that negative 4, guys, that sign in the middle changed. Okay, so we still have our x that we factored out at the very beginning. What is the new GCF? What's that new parenthesis I have created that I see twice? So I have 4x minus 3. And then what happens with x squared minus 4? Put them together. Now, am I done? Why not? X squared minus 4 is the what? Difference of 2 squares. Guys, think about this. You always have to say, can I factor a little bit more? This would be x, 4x minus 3, and then the difference of perfect squares would give me x plus 2 and x minus 2. How many x's, how many x equals did we say at the beginning that we should have? 4, because I have x to the 4th. Set each piece equal to 0. Do I have multiplicity?
Yeah.
No.
Do I have any x-intercept repeated? No. Positive 2 and negative 2 are two different spots on the graph. So I have x is at x equals 0, x equals 3/4, x equals negative 2, and x equals positive 2, right?
No, okay.
See it?
Yeah.
What about multiplicity? Do I have it?
No.
No multiplicity. So what's going to happen, guys, at the x-axis for all 4 of these intercepts? It's going to cross through. Awesome. Very good, guys. And now let's talk about our graph. Kaylee.
No, never mind.
Okay. Let's talk about our graph. General, all right? I have an intercept here at 0. I have one at 3/4. I have one over here at positive 2. And I have one over here at negative 2. Agreed? Now, what was the direction of both of my arrows? Both of them up. Both of them going in that direction. Now think, before you guys start going crazy with your lines, what should happen at each intercept? It's going to go through. So we're going to go through, 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 through. So you guys showed me the end behaviors of my graph. You showed me the intercepts, and you showed me at the x-axis what is going on at all 4 of those points. Does that make sense? Kaylee.
So if it's no multiplicity, is it always going to be crossed through then?
Mm-hmm. Yep.
Okay.
And it's if there's multiplicity an even amount of times. Like if you had x cubed equals 1. Right? All right, take the cube root. The cube root of 1 is 1, right? How many times would you really have 1? 3 times. At that point, that's a multiplicity, an odd number of times, so it would go through. But we don't have that a lot.
Will we have that on the quiz?
Chances are not very likely.